Salam sejahtera. Alright. For this topic, alright. So what if we have a fx equal to x cubed? Then we have gx equal to cos x. Alright. So we have a two. We have a two. If we have a single function, we can just uh, differentiate like in the previous topic. Alright, we just differentiate x cubed will equal, if we differentiate x cubed, we get 3x square. Then if we differentiate gx equal to cos x, we can get negative sin x. Alright, so what if we have these two function, we combine it, we combine these two function. How we gonna differentiate? Alright, so that's why in this topic, what we're gonna do is we're gonna learn how actually to differentiate the complex function like such this one. Okay. Alright. For this in this topic, so the topic is further techniques for differentiation. Alright, so in this topic we're going to learn how to differentiate a complex function or n combination of derivative. Alright, so we're going to apply certain several rules to differentiate this kind of function. Alright. Okay, first in this topic, first is product rule. Alright. So then second is question rule. Then chain rule. Okay. So this three topic we will covered in this lecture. Okay, first product rule. Okay, let's see. If you have a y equal to ux, vx. Alright, so ux and vx is a function, right? It's a function. Alright, so how we gonna differentiate for product rule? According to product rule, if you have a v times u times v, so how we gonna to differentiate is we will differentiate, and then this is the equation. How we gonna differentiate? We will differentiate first. We differentiate u, so we not gonna to differentiate u. Then we multiply with dv dx plus with v here. Then we will multiply with du dx. Alright, so this is the product. So this is the product rule. So you need to follow for this kind of situation, or for this kind of function. Alright, so let go to the example. Alright, so the example for product rule, if you have y equal to f x sine x. Alright, so u is x, v is sine. So v is sine x. Alright, so then we will differentiate x and sine x. So according to the product rule, right. Then we know that u is x, v is sine x. So we'll differentiate both. So what we're gonna get is dx sine x. So we know that d sine x, d sine x dx is equal. We will differentiate sine x, we will get cos x, and we differentiate x, we will get 1. Alright, so how are we going to put it? Alright, so according to the product rule is, so this is according to product rule. So x, we will differentiate d sine x dx, which is a dv dx. Then we will differentiate dx dx. Alright, so we will get x with x and sine x here. We will not gonna to differentiate. Okay. So the answer will be x cos x plus sine x. Alright, because of dx, x will get 1. Alright, so this is the final answer. So this is the product rule. Okay, so let's go to the question rule. Alright, so question rule is a little bit different from question rule. Okay, so question rule. According to question rule, is you have a one function ux over vx. All right. So if you have a one function ux over with vx. Okay. So you will get we get when we differentiate this two function. All right. So let's see. So according to the question rule, you will get 1 over v square, okay, times with v du dx minus u dv dx. So actually it's a little bit same like product rule, but we have a minus and 1 over v square here, and then it start with v here. But for product rule we start with u, right? So for our question rule, actually we start with v, and we have a 1 over v square here. So this is the question rule. So you need to remember this. So we have a product rule, we have a question rule, right? So let's see the example for question rule. All right. So when you have a y equal to x over v x plus 1, right? So we have a function, all right? X plus x plus 1. So we know that function at the above if u is u, and function in the below is x plus 1. All right. So function in the below x plus 1 is v. All right. So we know that these two functions, right? So we need to assign. So u is x, v is x plus 1. All right. All right. All right. So according to question rule is 1 over v square, right? So 1 over v square. All right. So v is x plus 1. All right. And let's start with 1 over x plus 1 square times with x plus 1 dx dx minus with x. All right. X is u here. And dx plus 1 over dx. Okay. Let's see what we get. All right. So we get same. Okay, the first part here is same, so we're not going to touch anything. All right, so last rule, which is a chain rule. All right, for the chain rule, all right, let's say if you have a y and then you have a y equal to yu. All right, so u is the function. It means u is a function. Okay, that's mean that in function you have a function. All right, so if you how we going to differentiate if you have a function, and then inside the function itself you have a function also. All right, how we going to solve it? All right, so we use a chain rule. All right, okay, all right. So this is according to the chain rules. If you have a function, right? If you have a function inside a function, right? So this is how you differentiate. So dy dx equal dy du, then du dx. That means here du dx, du here, u here you will differentiate according to x, and y here we will differentiate according to u. All right. So this is the chain rule. So you need to remember. All right. So you need to follow these three rules. All right. So okay. So let's go to the example. All right. So when we're gonna to differentiate. All right. So we differentiate like usual. The x cos 3x minus 2, but so we change the cos u here. So we will change cos 3x minus 2, and u we will equal to 3x minus 2. That's mean here cos here we function, right. So you will get cos y equal to cos u, and u is equal to 3x minus 2. All right, so you just replace the 3x minus 2 with u. Okay. Okay, then we differentiate u here. So u to the x, which is we will get 3x minus 2. We will get what? We will get 3. We will get 3 minus 2. Then we will get 3. Then we differentiate dy to the u. So we know that cos u. So we have already changed the cos 3x minus 2 with cos u. All right, we differentiate cos u to the u, and we will get 3 minus, we will get minus sine u. All right, so this is the in the previous problem that we solved. Okay, so okay, how are we going to solve it? All right, so we will get dy dx equal to, according to chain rule, dy du times with du dx. You will get minus sine u 3. All right, so equal with 3 minus sine u. All right, we cannot left this one. All right, so with this, because we have u here, so because our original equation is not u, right? So we need to change u. So we need to change u to 3x minus 2. All right, so we need to change. We need to change back to the 3x minus 2. All right, so this is the answer for the example. All right, so this is how you use a question. Oh, sorry, this is how you use chain rule. Okay. To my lecture. Okay, so good luck for your exercise.